Oh, no volunteers? Come on, you guys. Okay, Ezekiel, you're at the top of my leaderboard here. You get your mic?
Yeah, I got my mic.
Okay, so you can see the question, right? So consider the system of equations, blah 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 blah, equation one, equation two. It doesn't it doesn't really matter equation. You don't have to do that. It says let this be the point of intersection, and we know we can find the point of intersection, right? We can just close those off, and there's the point of intersection. Sometimes they're kind of hard to see, but it's right there where they cross. That's the intersection point, right?
Yeah.
Okay, you agree?
Yeah.
Yeah. Okay. So what is 50% of the distance between x star? So that's supposed to be the x value. So I can get rid of these and I can have it isolated. So the x value, remember, they're xy pairs, right? So here, the equilibrium value is listed first as 10.43 units. So that's our x value. Does that make sense?
Yeah.
And then the y value would be on the y-axis, the price of $62.71. So it's what is 50% of the distance between um, x star and the horizontal intercept of equation one? Now, the equations are listed in order. It's labeled demand and supply, and you could kind of see if you wanted to look at the equations at all that this is the one with the downward sloping line. It's the -3. See how I have that highlighted? So it's that one. So the horizontal intercept, we talked about this before last time, but the horizontal intercept is that place where the line hits the x-axis. So can you see that, Ezekiel?
Yeah.
And the x value there is what? You want to tell us?
It's 31 units.
Yeah, 31.33. And remember, we want to make sure we carry our two decimal places because otherwise we can get a little bit goofy with a rounding error. So we have 31.33 and and then the equilibrium point is over here in green. I could blow it up, but uh, where is it? Let me find it again. There it is. It's 10.43. So I'll put it back so it's over there. Yeah. So there. So we have 10.43 and and 31.33. So what is 50% of the distance between these two? Well, there's 10.43. I'm pointing down on the horizontal axis and there. And so what would I do for 50% of the distance? Do you have any idea?
Uh,
It's like halfway between those 2 points, right?
yeah.
Right? So I got to think about it. Like there are a couple of these. Well, probably by the time you get to the end of the course, there's more than probably like I don't know. Like let's say 40% of the questions that you're gonna see on Ignithium, you're gonna go, like I gotta figure that I gotta think about it, right? Um, so the information's there, but what you really want is, and I'll um, share a whiteboard with you, unless I can. Um, yeah, okay. I'll, I'll do a new share whiteboard. Okay, well, it didn't give me my whiteboard. Okay, okay, there it is. Can you see the whiteboard now, Ezekiel?
Yeah.
Okay. Oh, it's playing games with me. Um, okay, so I'm gonna draw a little version of the diagram here. Okay, okay. And so here's our equation one. Can you see that? And we said this was, what did we say it was 31.33?
33. Mm-hmm.
Yeah. So that's this point here. And I'll put a little dot there. And then our other one was,
Well, it was at the units were 10.4043.
yeah. And so I'm gonna put that here, 10.43, and I'll move it over there. And so how would we find the point that's like halfway between these? Well, we could do this. We could say, so the distance, so I'll put dist is equal to 31.33 minus 10.43, right? So that's the distance between the 2 points. And I would get some number. I don't know if you have a calculator, but
Yeah, I did
yeah.
it.
And then I could divide that by 2. So that's the point that's halfway between, or half of the distance. Now to find the point that's halfway between, then I would add the 10.43 plus that distance calculation, right? Because I want to start at 10.43 and I want to add half the distance and end up with the point in between. Do you see what I mean?
Yeah.
So that would give me, let's see, that would give me the value there. Does that make sense?
Sure.
Okay. So do you want to tell us what that value should be? I mean, I don't have my,
10.45. Wait, no, sorry, 20 point, uh, it's like 20.90 or, yeah,
yeah.
95 or something.
Well, I mean, you need a calculator to figure that one out, right?
Yeah.
So I'll do my little calculator here and just make sure I agree with you before we put it in. So 31.33 minus 10.43 is 20.9. Divided
Yeah.
by 2 is 10.45 plus 10.43, and I get 20.88. That's what I got. Is that what you got?
Oh, yes.
Okay.
Oh, wait, Professor, I have a quick question.
Yeah, okay, who's speaking?
Carlos Fanus.
Okay, go ahead.
Oh, why did you do all that? Why don't you just add the two numbers and divide it by 2?
Well, because well, let's be careful, right? I'll go back to the page, you know.
Because that's the halfway between the 2 points.
Well, okay, so let's see. What is 50% of the distance between x and the horizontal? Yeah, you're right. I could just put 10.45. I didn't actually have to look for the point that's halfway between the two. So I agree with you, right? So I should just be able to put 10.45, right? I thought it was asking for the point that was halfway between. So you got to read the questions carefully. Because yeah, it just says what's half of the distance. So that's fine. Okay. Now this is what we end up with, right? So let's check our answer and see what they end up with and see what they meant. Now, the important thing about this is that hopefully the question's worded correctly and there's no issues. But if you go through the practice and this is the answer, then you can be sure of the interpretation that we gave to it. So 94 divided by 3, that's our 31.33. And then, yeah, and then 94 minus 21 divided by divided by 7. Yeah. Okay. And then, so yeah, that's exactly the 10.45. Everybody good? Any questions?
Right here, sir.
What's that?
I have a question.
Go ahead.
Okay, so you say the distance of x. So the
Do you
10
want do you want
point
do you want me to go back to the whiteboard?
yeah,
Okay, okay,
really quick, yeah.
okay. It's gonna. I don't know if it's gonna let me. Oh, it keeps.
Okay, so
I don't know if you guys can see the diagram before or not. It's
I mean,
my.
we kind of see it, but it's just we see like half of the number, but it's fine.
Yeah,
Um,
it's kind of goofy on mine too.
yeah. So I have a question. So like you say the x, right? So the x is the equilibrium, or is that the intersection
Well,
of
yeah. To be clear about it, I'm gonna.
like what is the 10.43?
Okay, okay. Hold on, wait a minute. Let me see if I can make sure. Okay, so let me try to be clear. And actually, I read the question wrong, and so it's good we went through it together. Um, and so so let's find the equilibrium. It's the 10.43. It's here, right? So the question is just asking about half of the distance, right? And there's 10.43 here. Can you see where I'm pointing on the horizontal axis
Yeah. So
in the
the
corner?
x is the equilibrium, right?
Well, no, I mean, here we don't have equilibrium. If here, oh, okay. You're just talking about the way that they're labeled. Normally,
Yeah.
equilibrium is where the x and the y cross, and that's right. I don't have it there on the diagram, but yeah, that's. And if I put the other equation there, it's there. Yeah, that's equilibrium.
Yeah.
So, but they're just asking what's on the x-axis, the half of the distance between this horizontal intercept here and the 10.43 here, right? So just half of that distance. Now, what I had started to do was to find out the x value that corresponds to halfway between them. And some of the questions might ask you to do that, but this question is just asking us for half of the distance. And if we take the 31.33 and we subtract off the 10.43, then we have half of that distance. So that's all we
Yeah.
have to do.
Yes, sir. I understand that, but I'm trying to ask, like, I'm trying to confirm with you, like, how is the x equals 1043, and that's it.
Oh, here?
Yeah.
You mean for the equilibrium point?
Yeah.
The
So
point.
why say just like the x? So like it's like how do you know like it's the intersect or
Well, because it's given from the diagram, right? I mean, we could talk more about like the algebra of it, but you guys don't have to know the algebra of it. You should just be able to read off, the intersection point, which is labeled, EQM, from the diagram. Does that make sense?
oh yeah I know that's the intersection, but I'm trying to ask like why is that so when they say the x they say between x and horizontal
Intercept.
equation one yeah
Yeah.
so the x is the intersection the x is the equilibrium.
Well, okay. To be really clear, and I can show you guys this here. Let's see.
Oh, okay. Actually, I got it. I think the X is the 33,
Okay. So
31,
I'll
31.33. Yeah.
yeah, so it's being goofy with me right now. I keep trying to share my screen and oh, there. Okay, we're back. Okay, so let me draw one of the diagram and just we'll be clear and see if you agree with me. What's your name again? I don't remember.
Lawrence.
Lawrence. Okay, so Lawrence. So what you know is that if I draw any point, right, in this Cartesian plane, like there, right, it has a corresponding value on the x-axis and one on the y-axis, right?
Yeah.
So like here, I could label this as,
Oh, I can't see your whiteboard.
you
So
can't or you can?
I can't. Like I'm looking at
Oh, okay. Can you see it
the
now?
practice right now. Oh yeah, there you go.
Okay, thanks. So I'll call this x0, and there's the point, um, and this is the y value. I'll call it y0, right? So this point here, right, is a location on this graph, and it has a y value and an x value that describe its location, right? And so we said for the equilibrium point, and now I'll stop this sharing and we'll share this again. So I'm going to get rid of these two. So this is our point, right? And the x value is 10.43 and the y value is 62.71. Does that make sense?
Yes, yes, sir.
Yeah. So hopefully that answers all of the question, all of your questions. So are you all good? You feel comfortable now?
Yeah, I guess.
Yeah, would you guess? Well, is there anything you can speak now? You know, tell me what's the if there's still something lingering that's bothering you. Because if it's bothering you, it's probably bothering somebody else that's watching us talk. That's why I like to talk to somebody when we go through these things.
Oh, so I know. So when I say like, okay, so I say distance between X, right? So when you look at the like, can you like,
Oh, you mean like
so
X star? So
yeah.
yeah, so it
So
says
how do you find it?
yeah. So it says let X star Y star be the point of intersection. So this is giving the X value and the Y value for the point of intersection, which is our equilibrium point, right?
Mm,
So X star is 10.43 and Y star is 62.71. Does that make sense?
oh, okay. There you go. There you go. Right
Right?
there.
Okay.
All right, got it. Thank you.
Yeah, I know that's the reason why I like to go through these questions, because when you guys do it, your numbers are going to be different. So you can't just like, you know, like copy it down, and you have to understand what you're doing. That's part of the game
And then
here.
horizontal intercept is when you,
Yeah, and the definition of the horizontal intercept is this point here,
yeah.
where
So
the line intersects with the horizontal axis.
yeah, so
So
X is 0. Yeah. Okay.
yeah, so well, actually y is 0, see it's the second one in the
Oh
pair.
yeah, yeah. That's right. That's right. That's right.
So x is 31.33 and y is 0.
Okay. All right. I got it. That was
Okay,
the answer that I was looking for.
okay, great. So now let's go on to the next one. So consider the following system of equations, blah, blah, blah. What is the area of the interior triangle? Okay, So who would like to try this one? By the way, I have to say thank you to Ezekiel and Lawrence and everybody else for helping out with question number 11. Okay, so what about question, or actually question number 10? Question number 11. Who would like to help out with that one? Anthony, you have your mic? Okay. You
Yeah.
want to help us out? Okay. So it says interior triangle. You have an idea what it's talking about?
There'll be a triangle formed on the left, right?
Yeah. So I mean, if you were to look, like, and you can see my cursor moving around, right? So like there are a bunch of like potential triangles here. There's like this one, and maybe there's like some triangle up here, and I don't know. This looks like a trapezoid, but like you could imagine there's an X there, right? There's maybe potentially different ones, but there's only one that's in between both this equation and this equation. That's so the blue equation and the red equation that's well defined, right? And that's the interior triangle. And is that what you meant, Anthony?
Yeah.
It's this area here. And you can see it's a triangle. It's kind of like tilted a little bit, but it's a triangle. And if you were gonna try to measure the area of that triangle, right? You remember the formula for area of a triangle, right?
1/2 base times height.
Right, right. And so, and also I wanna tell you guys, and I don't know if you remember, if you ever I had a really good um, geometry teacher in the 10th grade. His name was Mr. Manitos. So I think he was Greek, because that's like a Greek name, and I don't know if you guys know, but I think the Greeks take their geometry super serious because they had Euclid. It's like part of their tradition. Anyway, he was a great geometry teacher. But one of the things he was kind of careful about is he was like, well, when we talk about height, it's not really well defined on a triangle, but you can talk always about altitude. And that's what people use sometimes. That's what they really mean. They say height, but they mean altitude. So I would say that, so here's the base, right? And from that base, you can give an altitude, which is to the equilibrium point where those two lines cross. So so would you, if you were to look at this, Anthony, you would say the base is, so
1 minus 19.
yeah, 108 minus 19, that measures that distance there. That's perfect. And then if I go over to the point that's labeled as the equilibrium, you can see the X value measures that distance, right?
Mm-hmm.
Yeah. So do you want to then do the calculation for us, and let's see if we get it right? So 1/2 of 108 minus 19 times 17.8.
792.1.
Okay. 792.1. Is that good?
Yeah.
Okay, I hit submit, and here we go, right? Well, you can kind of see here's the 1/2 here. And like I said, if you look at these formulas, then you can kind of, figure it out. But here is exactly what you started out with, right? It's the base, 108 minus 19, times 1/2. And this is that X value we were working with. It's kind of hard to see, but if you guys were to work out the algebra, you would see that the X value is 108. If you set these equal to each other, these two equations, it's 108 minus 19 divided by 5. And yeah, I don't know if you can do that. Can you do that on your calculator? 108 minus 19 divided by 5, and verify that it's our X value that we used, the 17.8, Anthony?
Yeah.
Okay, you got it?
Yeah.
Okay. So we got the right answer. Good job, Anthony. Thank you so much. So does anybody have a question about that one? I know sometimes people look at the interior triangle one and they're like, I don't know. But yeah, the information's all there. It just takes a little while to sort it out. Okay. So now let's look at number 12. Consider the following system of equations, blah, blah, blah. Again, we've got one of these things. Look at the point of intersection. Okay, so now this one is what is 50% of the distance between the origin and x star? So now, right, the origin here is 0. This one's even easier because all we have to do is look at the origin and look at the equilibrium point. So who wants to help with this one? Do we have a volunteer?
Right here.
Okay, who is it?
Lawrence.
Okay, Lawrence, tell us.
Okay, so first we so 0, right? And then the equilibrium is 9.86.
Yeah, that's the x star, right?
Yeah, so what you're gonna do is you take 9.86 divided by 2.
And that'll be the distance.
Yeah, there you go.
So what did you get for that value? You have your calculator?
That'll be 4.43.
43. Okay.
Yeah.
And there we go. And then you can see again, right? This is our x value that you were just using. You can verify that 95 minus 26 divided by 7.
Yeah.
And so 4.43. So we get the right answer. So let's take a look at 13. Y star is the value on the y-axis of the point of intersection. What is the area of the triangle formed between equation 1 and y star? Okay, so now this one is even a little bit more subtle. So let's see if we can. Carlos, are you there?
Yes, I'm here.
Okay, so you want to help us out with this one?
Sure.
Okay. So it says we want equation 1. So actually I could get rid of equation 2, right? I don't really need it because I still would have the point of intersection here, which is labeled as EQM, right?
Mm-hmm. So we could just do one. Let me get my calculator.
Now I'm going to move to the whiteboard for just a minute and see if this so if I read everything correctly, and you can make sure that I wasn't being too quick like I was being on the other one. But Carlos, can you see the whiteboard now?
Yeah, I can. I can see the whiteboard.
Okay. So our
So I know the height was, I think it was 94 before you switched.
yeah, I think that's right. I just want to, we'll go back to it in just a second and just see if you agree with me. But let's just say that, and I'll pull this down just a little bit. There, and then if I can, there's the line. I want to pull this little point down, if it'll let me. Oh, it's being, okay. It doesn't want to let me pull it. I can change the size, I just can't move it. Oh, there we go. Okay, so I just pull that over here for a minute. And here's our line. And this was our equilibrium point, and we had our values there, right? So it seemed to me what they were asking was the area of that triangle there. What do you think, Carlos? They
Can I
meant,
go back and read the problem real quick?
yeah. So I think it's that triangle there that they're talking about. Except for one other thing, I'll just, to be consistent with their notation, I'll note that this is like y star. That's our equilibrium point. Okay, so stop share screen. There. Okay. So they want the area of the triangle formed between that equation 1, we have that, and y star, right, which would be that y value over here from the equilibrium point, right? So it's a right triangle right
Yes.
there. So did you calculate it for us yet, or so we agree on what they're asking for then, at least?
So the height of that is 48.5, correct?
Well, so yeah, the y value is the second value. It's 48.5.
So I got 147.88.
Okay, and just so you said 147.88.
Yeah, let me just double check it.
Okay, and I'll go a little low tech on you and show you a hand-drawn diagram. 48.5 and 94. And 6.5. So does that look right? The triangle we're talking about. So the distance is the vertical intercept is at 94 there,
Yes.
and then you said that height is whatever 40. What did we say? 48.5. So you got to do the 94 minus the 48.5 to get the altitude there.
Which is 45.5.
Yeah, and then multiply it by the distance on the base, which
Which
is
is
given.
6.5.
Yeah, and then multiply by 2.
Yes.
And so what'd you get?
I got 147. So how do you want me to round the answer?
Well, to 2 decimal places would be great.
Okay. So 147.88.
0.88. Okay. Now, so you see this, and here this is exactly what we put into the calculator, right? There's our 1/2. And this is the 94 minus, this is our y star. Okay, so that's the 48.5. If you go ahead and calculate that, you'll see that's 48.5. And then this is the x value, which is the 6.5. And you can verify those. Okay. Now I'll also next time we get together, I'll show you guys another little.
Yeah, I just verified it. It was right.
Okay. Yay. Okay. Thanks so much for your assistance. But I'll show you guys another little trick, playing around with the tools available here that will make it even easier for you guys to verify your answers. But it's just a way to, like I said, there are a couple of little things you can do that are helpful. As we go into the homework, I'll show you. And like I said, that's the homework quizzes that we're assigning. The practice is you can just do as much as you want, but the other one counts for points. So you want to do the best you can there. So okay, so question number 14. Consider these two equations. We have our point of intersection. What's the area of the rectangle formed between equation 1 and equation 2 at 50% of the distance between the origin and x star? So who wants to help me with this one? Okay. Okay, how about Morgan? Are you there? Morgan? Uh, maybe Morgan isn't there. Morgan, the reason why I call on you is because I really like your flower picture. Yeah. How about Cheyenne? Though I don't know if Cheyenne has a mic. Can't really tell. Okay. Yeah, it looks like you have a mic. Cheyenne? Okay. How about Isabel? Isabel Mendez. And remember, you can always respond in the chat if you're having a hard time getting your mic working. That happens sometimes to some people. Isabella. Okay. Okay. How about Christian? Are you there?
Hello?
Okay.
Yes, I'm here.
Okay. Is this Christian? I can't see your full name. What's your last name?
Aguayo?
Okay. Okay. Christian Aguayo. Okay. So Christian, do you have a camera or no?
No.
No. Okay. That's kind of because actually what I'd like somebody to do who has a camera just to draw a picture of the rectangle if they can. So what about Nicole? Are you there? Nicole? Okay. Bruh.
Yeah, I'm here.
Okay. Do you have a camera?
Yeah, unfortunately.
Unfortunately, are you shy? I have one of my daughters. It's so funny. So my youngest daughter is 13, and she has a really good personality. But for some reason, they make them do these presentations and everything like that in junior high and whatever. And she's a really good presenter, but it drives her nuts. She gets really like stage fright or something. And so she just told me, she's like, I hate presenting, but she's so good at it. So, um, so Nicole, if you can, draw us a picture and show us your picture of what the rectangle should look like. Can you work on that? You gotta
What?
draw us a
I'm like,
rectangle.
I'm like confused.
Okay, well let's talk through it then. Um, and is Daniel there? Daniel Benitez?
Hello?
Yeah, Daniel. Do you have a camera too?
No.
No camera. Okay. Because well maybe you can help walk Nicole through it. What she should do. Do you have any idea?
I'm kind of lost on it. I don't know exactly where the
Okay.
rectangle should be.
Okay, good. Well, we'll figure it out. What about Dawn? Oh, Spencer Rains is volunteering.
Yeah.
Don, are you there? Don
Yes,
Averia?
I'm here.
Do you
Yeah.
have a camera?
Yeah.
Can you help?
Sure. But
Okay.
I'm also not 100% sure what to do, but I can help for sure.
Okay, yeah.
Oh, you
So
want the camera beyond.
yeah. Okay.
Do you want me to draw a rectangle or something?
Yeah.
Yeah, for sure.
Totally. So I'm trying to find you. Okay, there you are. Okay. So how do you turn a triangle into a rectangle?
Uh, um, I'm not sure.
And Spencer, do you have your camera? Because vol means you're volunteering, right?
Yeah, I do. I think I got it.
So okay. Is your camera on, Spencer?
Now it
No.
should
Okay,
be.
there you are. Yay, Spencer. Okay.
Yeah. Let's see. I write pretty small, but
You can always write bigger.
yeah.
Okay.
So this is our intersect. So I took basically this midpoint here.
Yeah.
I draw a line straight up,
Yeah.
and then I just drew two more straight lines directly to the origin. So I get this little rectangle
Yeah,
here.
yeah, to the vertical axis. Yeah, so you get like a little
Yeah.
rectangle in there, right?
Mhm.
And so it's a little bit complicated to, look at all the pieces, but once you do, it's right there, right? It's not, you know, it's not like crazy complicated, right? But
Yeah,
the
it took
one
me a
thing,
while to figure it out, but
yeah. So there are probably, I would say, 10% of the problems. Like I said, 40% of them make you think a little bit, but maybe 10% of the problems that you guys are going to see that are like this, where you have to be like, okay, what are they really talking about here? So can everybody see Spencer's rectangle? Nicole, what do you think of that? Can you see it? Nicole? She says it looks good. Okay, now, and then Dawn, can you calculate the area for us, or do you see
Of
what
the
Nicole's doing?
rectangle?
Yeah.
Okay, yeah, sure. It would be the midpoint of, wait, can I just
So
draw it out real quick?
yeah, that's what I would do.
Yeah.
So I'm gonna go ahead and look carefully here. It says 50% of the distance between the origin and X star. So X star there is 8.5. So half of that is going to be 4.25, right? So I'll look over here. I'll find 4.25 someplace, I do believe. There it is, 4.25.
Mhm.
And so can you see, Spencer? I can get the height at 4.25, which is 42.75 on the red line, right, Spencer?
yeah.
Yeah. So that's one of the y values. I need to calculate the height of the rectangle. Then 4.25 at 76.75. So I'll have 76.75 minus 42.75, right?
Yeah, so that would be for 34.
Okay, yeah, 34. And then I just have to, that's the height of the rectangle. And
Mhm.
then the width of the rectangle is
Would be
just,
4.25.
it's just 4.25.
Right. So then 34 multiplied by 4.25 is 144.5.
144.5.
Yeah.
Drum roll, please. And boom. Okay, we get all that stuff. But I could tell you guys, so here, so this is 1/2 of our distance. That's our 4.25 there. And here is the difference in the height between the blue line and the red line evaluated at 4.25. So I say to Spencer and let's see, and to Dawn and to Nicole. Okay, thank you guys. Good job. We did it. Or you did it. We did it together. But just remember that all of these, when you actually do your practices and your homework, the ideas are going to be the same. The numbers will be different. And I have one other tip for you guys. And this is a quick tip. And that is when I send the homework and you do the homework the first time, the first answer you put in is immediately saved to the database, and that's what you're scored on. So it's your first answer. That's how it's like a quiz. If you put in another answer, it'll accept it, but it's not going to score it. So you could just keep submitting answers if you wanted to, whatever. But if you get to a question and you don't like it, right? You're like, like it's too hard to see. Sometimes the diagrams are yucky or whatever. One of the things you can do, and this will become more important a little bit later on in the class, but you can just reload the page and it'll give you a new version of the problem. And as long as you have not answered that problem, you'll be scored against the new version. So if you want to, you could be like, like I don't like this diagram. I can't really see things very well, even though I click things on and off. I can't really see, because the lines look bizarre or something. Just reload it and get a new version, one that you like, one that you're comfortable with, or as comfortable as you're going to get. And for the ones that you already answered, if you're really not sure if you answered it, you can answer it again. If you know you answered it, it won't repopulate your answer because it's going to be against new numbers, right? But you'll be scored on that version you answered, so you don't have to worry about it. So if you do, let's say you do questions 6, 7, 8, 9, and then you hit a new version and decide to continue on with questions 10, 11, 12 through 14, or you can do that. Just keep track of which ones you've answered so you don't, do more work than you have to, and answer it again. And I guess the one other thing too is it also gives you the flexibility that if, you leave the website or, most websites, including this one, have basically a 90-minute time frame before they automatically log you out. So if people are really slow and they're taking their time and maybe they're chatting with a friend or they're on Instagram or Snapchat or something like that, it's always worth it to when you're getting ready to answer the questions, relog in or refresh and make sure that you're logged into the page to answer the questions. But you could I'm going to give you guys about, 5 days to do the homework quiz. But if you want to answer a couple of the questions and then go do a reading assignment for another class or do something else and then come back and log back in and get a new version. If you already answered some of the questions, you don't have to answer them again. And you guys will see that as we go through the material more. But again, the one other thing I'll caution you about is try as best as you can to adhere to at least the 2-digit precision, because if you get sloppy, your rounding error will be too big and you'll be scored wrong. And I won't fix that in general. Like I said, when I download the scores at the end, I widen the window a little bit, but it's just a tiny bit. So if you're not careful, then you'll end up losing points just because you weren't being precise in your calculations. So anyway, yeah, this assignment or homework quiz will be ready for you very soon. I'm going to do it, like I said, as pretty soon after I get off with you guys. So rather than introduce new material, because we're running a little bit short on time, we only have about 5 minutes left. I just wanted to make sure you guys were ready for the homework quiz when it comes up. Does anybody have any questions before we sign off?
Right here.
Who's speaking?
Lawrence.
Okay, Lawrence.
Okay, so when you submit your answer, does it show that it's right or wrong?
My dog's barking. Yes, but I'll have to show you how to verify that information. And I'll do that in about a week. But there's a way. But you won't get an immediate like yay or nay right away. So
Yeah, sir. So when you put in the answer, I'm just trying to clarify. So you put in the like the answer or like how like the whole equation, like how you do it?
No. It's and I said this in the other thing. Remember, like we've been doing here, when you put 147.88, that's what Ignithium's looking for. It's looking for a decimal answer. Some people have tried to put in equations before, and it's very unreliable. It's not looking for an equation. It's looking for a number answer. Okay.
Yeah.
And the only reason why I set the feedback to show the calculations was because I've had students in the past say, and it's kind of hard because Ignithium is random. So there's so many different possible versions of the questions. It's not even 100. It's like 10,000, like they're like a lot of different versions that could be displayed. And so it's hard for me for a student to come and say, hey, you know what? I don't think it scored me right. I think I put in the right answer. And then I have to say, well, I don't know exactly what version of the question you had. I don't know like all this stuff. But if the feedback has the calculation, then the calculation will be the same for everybody, but the numbers will be different. You know what I mean?
Yeah.
So everybody can see, oh, well, this is how the calculation was performed to score me. And so I thought that was a better way to do the feedback instead of saying, well, there's just some mystery black box and it calculates numbers and, you can see your numbers matched or they didn't. And, that I think could be frustrating when you're playing for points. On the practice, maybe it doesn't matter as much because, you could do it 10,000 times, but still you'd rather do the practice and know what's going on before you actually do the homework quiz, right? So anyway, you can if it gives you feedback and you ever think it's wrong, you can always take a picture of the equation or something like that, and we can talk about it because we can look at a version. It might not be the same version that you went through, but we can look at the feedback from Ignithium and say, okay, we can see here, this corresponds to this point on the graph. This is X star. This corresponds to this distance on the graph. And, we can figure it out pretty easily. Though, I will caution you about one thing. And like I said later, it's kind of a mixed blessing. There's some things that are good about it and some things that are bad. And the one thing that's bad is that as we get a little bit deeper into the course, you'll see that some of the feedback equations are really long. Even though they're talking about something simple, like a rectangle or some special area on the graph that you can see, the equations, if you worked out the algebra, it's really long. So, but at least you'll be able to see where it comes from.
Yeah.
Okay.
Also, how many so when you submit your homework, so how many chances can you?
One. That's why I said it's like a quiz.
Oh, okay.
The practice is not scored, and you can do it 10,000 times if you want to make sure like you're understanding. But when you actually do like the homework quiz thing, it's one shot. It'll score the first answer and that's it.
Oh, okay. All right.
Okay.
All right. Thank you.
Okay. You're welcome. All right, everybody. I'll be making the assignment available soon, and I'll post an announcement on Blackboard, and I'll see you guys soon. Take care.
All right. Thank you, Professor.
You're welcome. Bye.
Thank you.
see your
Have a good
dog?
one.
Are the lectures?
See the big Tasha. Come here. Can you come here? Come on, big dog. Okay. Tasha. Come here. Come here. Come here.
Oh, she's shy.
Big dog.
Right here, big dog, big doggy.
Oh.
Yeah, she's a good dog. You guys are supposed to ask good for what? Good for barking. Okay. All right. Take it easy. Bye.
Thank you.
You're welcome. Bye.